CloudDB, shaping your new normal.
All right, welcome everyone to the 2021 APEC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages: English, Japanese, Korean, and Chinese. And please remember to register to as many sessions as you can. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now for today's session, Oracle Database Nest 21C by Stefan Oehrli. Hopefully I pronounce your last name properly.
Yeah.
Please feel free to write questions at any time during this session at the chat tab of the live webinar, and the speaker will be answering them at the end of the session. If there is any issues during the presentation, please feel free to contact me at any time by using the chat, and I will try to help you the best I can. Now, without any more delays, I would like to leave you with this amazing session by Stefan Oehrli. Stefan, the room is yours.
Hi, a warm welcome from my side. I think you have most of you have quite early in the morning. Here it's late in the night. I'd like to introduce myself. My name is Stefan Oehrli. I'm working as a platform architect in Zurich, Switzerland. I have a bit more than 25 years of Oracle experience. My main focus is database security, backup recovery, and more or less everything around securing databases. I work for a company, or I used to work for a company called Trivadis, and we now have been acquired by Accenture a couple of months ago, or better, 4 months ago. Trivadis itself is mainly working in Germany, Switzerland, and Austria. And since we are now part of Accenture, we have a wider focus around the world. Then I don't want to spend more time on Trivadis or Accenture or myself. Let's jump into the topic. We're gonna have for today the following agenda. I will give you a short introduction to the topic, and also a bit the motivation why DB Nest, PDB isolation could be important. I will show a few measures of Oracle 19c and below. And then we're going to have a look up about the DB Nest architecture, DB Nest configuration. We're going to discuss a few internals. I will provide you a short outlook, and I will finish my presentation with a conclusion. So how do we use a container database, or why we do use container database? I mean, when we speak about 21c, then it's probably no discussion that we use container database. With 12, 18, and 19, we had the choice to choose a single tenant database or a container database. But as of 21c, we don't have any possibilities. Every database will be a container database with at least 2 PDBs. So I did use I do use container database here in Switzerland to build up a private database as a service. And under this circumstance, I had the need to secure this environment a bit more than just on a plain installation. So container database could be used to simply replace a classic DB, a non-CDB. It can be used to consolidate multiple PDBs onto one environment, or as I mentioned, to build up a private or a public DB as a service. Another point which we have to consider when we consolidate this environment is what kind of data do we consolidate? So do we have a corporate structure behind of it? Is there data from different legal entities? I mean, the private database as a service, which we build up, we're going to host DBs from different companies. So there is quite high requirement or need to separate this data. Yeah, and then it could also be things which we have to consider is how we do set up the architecture itself. Is it cloud-based? Is it on-premises or dedicated hardware, virtual environments, etc.? These are all aspects which we have to consider when we build up the whole environment. So the isolation and the measurements which we have to implement, they may highly vary depending on the reason how we use container database, how we set it up, and yeah. We have a couple of risks in such an environment. I mean, we could have a PDB admin in one PDB which is doing some kind of privilege escalation and which exceeds the boundary of a PDB. This is one thing. Another thing is that one PDB could potentially use really a lot of shared resources, means memory or CPU power. There is also a possibility that somebody is escaping a PDB and gaining access to a LAN environment. I mean, when I bring up the PDB, the private DB as a service environment, we set up everything, and there is no ID, or there is not the ID that a customer is accessing the network and going to the backup LAN or the management LAN. So he should only be limited to his own customer LAN, which is attached to his PDB. And then another reason is that somebody could gain OS access from a PDB and become Oracle, and then via OS, he then again access all the PDBs or the CDB root, etc. So these are all risks in a DB as a service environment or in a container environment. The thing is, then you probably say, yeah, but how exactly, or what are the reasons for this, or how we can use and access this environment? There are basically 4 or 3 critical features. One thing is the Oracle JVM, DBMS schedule, and the external table preprocessor. You're probably asking why. The reason is that you can run OS commands with the JVM, so that every command which you run with the JVM on the OS is then executed as Oracle use, as OS user root. Sorry, not OS user root, sorry, as OS user Oracle. And this means then you could potentially become the OS user Oracle from within a PDB. And if you're being Oracle, you then can run everything as a user Oracle, means also you can gain access again to the other PDB via the OS. DBMS scheduler, you have the possibility to run OS scripts. Same with the external table processor, you can run preprocessor script, and these are normally run or executed as user Oracle. Again, here, if you can modify a script on the OS, if you can upload scripts and then you can run them, you can run stuff as user Oracle. The question is why isolation at all? The problem is that only basic database security is not enough. Usually the PDB admin has a lot of privilege, at least in a DB as a service environment, because you want that this PDB admin, so the admin of a PDB, can do whatever he requires to do. He usually have somehow a full DBA role or a restricted DBA role, but still a lot of privilege like system alter session. He can run PLS code package and procedure. This is one thing. And then the other thing is, as I mentioned, the feature, which I mentioned before, the scheduler jobs, OS calls, external table. So these are all things which brings it up that we may have to implement certain isolation. And then one thing which we will discuss later on also a little bit is the resource management. Because usually you don't have the possibility to control the resources used by a PDB. And we had this environment with a 12C or an 18C DB that we have a multi-tenant environment with around 20 PDBs. And one of these PDB was using extensive resources, and the resources were so high that the other PDBs, they had issues and brought up problems on the whole environment. Then the big question is this only an Oracle-related problem? No, it is not, because you see here a picture, a schematic diagram of a Docker environment. We have the infrastructure, the OS, the Docker environment. On top of it, we have the Docker container with the binary and the libraries, and then the application itself. We have similar issues there that a hacker could gain access to an application A. He can use vulnerability within the application. Could be old software, could be bugs. And then from there, he can extend an attack to the host or to other hosts via network, to other containers, to the Docker daemon, etc. In this particular environment in Docker, it's a case that Docker itself is running as root, so he could really gain access and do nasty things. So if you don't implement certain best practice, certain measures, you have the possibilities to become root on your host OS. So this means Oracle is not alone with the container architecture, and it's also not alone with this isolation topic. And that's also, we see it later on, that's also the reason why Oracle is starting to use similar concepts as we have it in other Docker environments. Sorry, as we have it in other container environments, not only Docker. You can probably ask, yeah, but this is only for large cloud deployments. Yeah, that's sure, it's the case. If your containers do look like this on the picture, we have everything well formed, everything is nice, stacked on top of each other, then probably it's not really a reason to implement certain isolation. But sometimes one container could look like this, that he is getting destroyed, or it could even be worse, that one container brings the whole ship down just because he ran out of resources, he bring up the system, or he has bugs and somebody gain access to the OS and crash the system. So there are plenty of reason why it could happen. So it's not only for cloud deployments, it's also something which has to be considered for on-prem setups. Since the container environment, the container architecture is default as of 21C, you definitely have to consider what you have to do with and how you have to set up your container environment. And one reason could also be I'm currently involved in a project with sometimes classified data. And if you have classified data, it could be a reason that you say, okay, my PDB1 is more secret and more critical than PDB2, but we still want to consolidate this. And then it's definitely also a reason why you have to consider some kind of isolation. Yeah. Just another picture. So if you have noisy neighbors, you probably don't want to have a container which does look like this container of the picture here. Yeah. Then we have other reasons like vulnerabilities, bugs, security requirements, shared resources, etc. So there are plenty of reasons why it makes sense to at least consider isolation and to start thinking with, okay, what kind of concept do we have to follow? What kind of concept do we have to implement? Let's start with the measure we have with Oracle 19c and below. You see a picture here again with a simple container database with the root container and with two PDBs. We have basically a few simple measures which we can implement with a 19c database. There's one thing called the path prefix and the create file destination. These two configurations are intended to be used to limit how the OS can be accessed on the file level. The create file dest is quite obvious. This means that with this I do specify where my data files will be created from within my PDB. The other parameter is the path prefix. And the path prefix is defining where my directory objects will be created. With the path prefix, I do limit the path which a PDB can use to create Oracle directories. The path prefix has to be specified when I create a PDB, so this cannot be changed afterwards. Then there is another parameter called PDB OS credential. With this parameter, I can limit how certain jobs do access the operating system. In particular, the scheduling jobs, I can define an OS credential, and then each scheduling job which doesn't have any credential specified will then use this OS user and with this credential. So the idea of this is that I really limit scheduling job processes to a dedicated users. And then the most powerful feature is the lockdown profile. With the lockdown profile, I can restrict certain operation and functionalities in one PDB. I can define lockdown profiles on the CDB level, which means this is then valid for all PDBs, or I can define or enable certain lockdown profile for a specific PDB. With lockdown profile, I can really restrict any kind of operation. I can say that the user can run an alter system, but he's not allowed to run an alter system kill session, or I can allow a feature like I can disable or enable OS access. I can disable Java. I can disable Java OS call. So it's quite powerful to configure how my PDB is executing certain features and functions. Now, the big problem is that these features are quite new. They are well, but they are not covering everything. One thing is that the isolation itself is not a complete replacement for a comprehensive security concept. So you still have to set up hardening. You still have to set up a user concept, role concept, etc., for your database. So this is the fundament. That's something which is mandatory in any case. And these measurements which I mentioned before, path prefix, lockdown profiles, and PDB OS credential, we cannot use them to control and manage any kind of resources on the system. So it's still then, if PDB1 is running out of resources, it's using all CPU power, then I could be in a deep shit that my system doesn't work anymore, doesn't respond anymore. And also TDE, in particular, the key management requires additional feature and additional measure if I want to separate it as well. Besides this, OS-specific administrative activity are also not covered, backup recovery, etc. So this is this basic isolation feature which I have. They are just limited, as I said before, directory access, PDB credential, and the lockdown profile. Yeah. The problem here is that if I make too complex lockdown profiles, then I potentially can run into a flow that can build up. So too complex isolation, a too complex lockdown profile. At the end of the day, I could even open a security hole because I just make it too complex. So everything is a bit shaky and requires a few more measurements. And that's also one of the reasons why Oracle started to introduce this new architecture called DB-Nest. The DB-Nest has been first available in Oracle 20C. So this was the release which has unofficially been released a year ago on the cloud. It never has to be officially released, so it's not available from on-prem. But it was the first release, including the DB-Nest. And it's now officially available in 21C, this DB-Nest. And the idea of DB-Nest is that I have, with this feature, the possibility to control OS resources used by a PDB, to even limit the file system. and isolate the file system on a per PDB level, enable secure computing, etc. The concept which has been implemented is quite similar to other technology like Docker. So Oracle is using the Linux namespaces, using C groups, using secure computing, etc. Here you see a big picture of this architecture of the CDB nest. We have a content database with a root container on the left side. Then we have two DBs or two PDBs with its own nest. It has a limit file system. It has its data file. It has a CPU memory assigned. So each DB or each PDB is then running within his limited scope of resources and processes. So the goal of a DB nest is basically to limit and protect a PDB. It enables the database to run in a protected and virtualized environment. The DB nest isolates the database from another database instance, from other application, and as well from PDBs and below each other, and from the CDB as well. So if a PDB is running in a DB nest, you cannot access another PDB from this nest because it's really limited within this DB. We see here how Oracle is using this, or how Oracle is starting implementing this. On the operating system, OS resources like process ID and user ID, etc. are assigned to a nest. Oracle allows to implement the file system isolation, so it's some kind of a pivot root or a change root, as you could probably know it from web servers, so that a DB nest sees its own new file system. It doesn't see the whole file systems, it only sees the mount points which are attached or assigned to a nest. The bind mount enables as well that only certain contents is visible within a nest. Beside this, the DB nest are using Linux namespaces so that the processes within a nest are limited to a certain amount of processes. A DB nest doesn't see then the whole processes as it would see running normal. Beside this, it is planned to implement the resource management so that you can really assign and control the resource of a nest, so that you can specify and say, hey, my nest is only running on 2 cores, and it gets exactly 100 megabyte of memory or 10 gigabyte of memory, so that you really can limit the resources which are available to a nest. Beside this, it implements something called secure computing, C groups, and the secure computing we see on a later slide. This is a functionality from the Linux system where certain the OS calls or system calls are filtered out, so that system calls which harm the system will be filtered out or not allowed. The configuration of a DB nest, so the basic configuration of a DB nest, is relatively simple. So let's have a look. Basically, there are 2 things which we have to configure. One thing is that we have to set up a bunch of initOra parameter. First of all, we have one parameter called dbnest enable, so where we're going to enable the DB nest. Then we set DB nest the file system configuration, where we could specify a configuration file where we list certain path and mount points which are available within the CDB. Beside this, the DB nest requires that we reconfigure the listener. We have to configure the dedicated through broker listener and have to enable this so that the access to this DB is then only using it's only going through this broker listing. The DB Nest itself does add a few new command line tools, basically DB Nest and DB Nest Init. I'm going to show them later on. In particular, DB Nest is the tool which is then used to configure the nest at a later stage. DB Nest requires a few OS package. One is the name service caching daemon, and the other thing is the system security service daemon. This has to be installed, at least it has to have installed on 20C. I think it's automatically installed on 21C if you set up the this RPM from Oracle, the default configuration RPM, when you set up an Oracle Linux or Red Hat Linux system. So to enable the DB Nest, we have to set on or enable this broker listener. It's one thing. We add this to the listener.oral, and then we restart the listener. We have to enable the broker without the system, and then we have to set and enable the nest, and we have to restart the database. Then we can check the alert log. I'm going to show this shortly in my test environment. Just going to make it a bit larger. So. First of all, we see here my listener.dora has been configured that I use the dedicated broker. So it is enabled. I did this before. Then short for this. So I set the DB Nest enable. And then I also set the other parameter, use dedicated broker, to true. And now I have to restart the database. And the thing which I'm going to do now is I just run a startup force, and you will see I will receive an error. That's expected behavior. Just take a second till my database is restarting. But you see, I do get an invalid username password logon denied. And the reason for this is, see here my database is in mount state. The reason for this is that I'm forced to use a dedicated broker. And that's also the reason why I cannot use SQL plus /as sysdba. I will run into this username password denied. It did work on 21C, but it doesn't work anymore on 21C. I did discuss this with Oracle support, and as far as I understand it, so far it is an expected behavior, so that you have now access to the database with you have to log in. I mean, I have my password stored here. I just use sys and log into the database, and I can access it. Of the database mount. The database is open. So as we see, that's the first change which we realize when we use DB Nest. As said, we see in the alert log that the DB Nest is available. Here is my PDB open. The PDB which I have is called PDB HR with the HR schema in, and here above we see that my PDB has been opened with the DB Nest PDB 0003. So you see in the alert log, this database is running in a nest. I said there is this new command line utility dbnest. When you run it, you see there are plenty of of commands available and parameter available. So initializing the nest, destroying a rest, creating nest, and configuring a few things. The tool itself looks quite promising. It is currently not yet fully documented. Means that I tried a couple of things to configure my number of CPUs, to configure my number of memory, etc. But it did not yet work. You could currently do quite a few limiting things. You can CU a nest. You can enter the nest. Means you enter the environment of your DB nest and check it and configure the isolation and the seccomp status. But as of now, with the current release, the functionality at least are limited or seem to be limited. I just run dbnest to list my nests which are available. As you see, there are now the root container which is open, my seed database which is as well in a nest. There is no isolation defined. There is no seccomp status defined. And I have my PDB HR, which has a default config and an access level, which is strict. This has been configured by default when I was setting up the nest. Yeah. So DB nest. And also entering the nest means I could enter the namespace on the Linux environment. So I could do this for for the nest 02. Then I'm entering this namespace. I can also try to do this with PDB3. Sorry, the nest 3. If I do this here, you see that I run into an error. And the thing is that this nest is limited in terms of file system and file system access. Basically, the nest itself does not have a shell. Means it cannot access bin bash, nor can it access user bin bash. So this is limited by the default configuration which has been set up by Oracle. What we can currently do is we can create our own blacklist file. So we can create a file. We can name this whatever we want to name it. And then we add files in it or mount points which we want to provide access or which we want to not provide access. Here we have an example with bin and user bin. And I can set the parameter dbnest db file config and add this file which has been created by me. And then I can limit access to certain environments and critical file systems. Yeah, the command which I mentioned already, the dbnest utility. As I said, it's currently not documented. It seems to be quite powerful for configuring the nest, but as no configuration, no documentation is available, it's quite hard to find the exact syntax that you can configure the nest. A few internals, just as an idea how the whole thing is working. We have here the kernel namespaces as Oracle is using it. That's a normal Linux feature. It is used to set up some kind of virtualization of system resource. We have an example picture here for a Docker container. We have a Docker container for Java. Externally, he has the process ID 332. And this Java process itself has internally in its container, it gets a new process ID. So externally, we have the normal process tree. And within the container, we have a dedicated new process tree. And that's also how Oracle is using the namespaces within DB Nest, so that when a DB Nest is launched, Oracle creates a namespace or set of namespaces for this nest, and the nest itself then can see the processes within its own namespace. Namespaces can be limiting different things. It's possible to limit the defined process namespace, but also user ID namespace, and also mount namespaces. So it's possible to configure a namespace in a way that it can only access certain resources, certain network resources, for instance, or certain mount points. Then the other functionality which is used, that is SSComp, so secure computing mode. That's also a Linux kernel feature. And the basic idea behind this feature is that it filters out system calls which are unnecessary or which are malicious, so that it's not possible to run critical features. So the actions are restricted within the container, and the feature itself is also used in other tools like Docker, like Podman, etc. Then the next part, that's the C groups. C groups is also a kernel feature. It is mainly, or it has been introduced in 2007, and that it used this quite heavily on Docker container, because of it. Within Docker container, you can really limit certain resource to a container. So we can define that a Docker container is just using one CPU and this amount of memory and etc. And it is foreseen that this is also part of the DB Nest. As we could see in DB Nest here in DB Nest tool, it is planned to have something here, but as far as I understand, the features available with this first release of DB Nest, the C groups is currently not yet implemented or not yet available. But the idea of C groups is really that we can hardly and limit the certain resources to a container. This brings me to my last couple of slides with an outlook. Currently, DB Nest is available in Oracle 21c, and the 21c is, as we all know, it's an innovation release. This means it's really up to use and to start your innovation, to start to test a few things. It is definitely not productive, and it is definitely nothing which you're gonna roll out in the next 2-3 months. But it's definitely something which makes sense that we start to look into it, that we start to consider something for our future architecture. Oracle will definitely, or has to, introduce more documentation, enhance the configuration example, because the information which is currently available is relatively limited. You do not find more officially documented, as I did show you. You can enable a nest, you can configure the nest, you can configure certain mount points, bind mounts. That's it. Yeah, it has to become mature, and I guess it is, as far as I understand the presentation which I already had from product management a while ago, that's definitely something which is coming fully and completely available in the next major release, which is 23C. So, to sum up my presentation is, in midterm, isolation will be a mandatory part, because we only will have container databases, so we have to consider what kind of isolation we will implement. So we probably have to consider lockdown profiles and the basic functionalities. I think this is something mandatory which we have to consider in our security concept and database hardening activities. DB Nest itself, it's really something which looks promising. It's definitely something which goes in the right direction, because it is a similar approach are used for Docker, for runc, for Podman, etc. But it's definitely really, really still a bit shaky. So we can start using it, we can start get some experience, but the documentation is very slim. You don't even have to look for metalink nodes. Haven't found one in the last weeks. And the documentation in the Oracle documentation, it is there, and it's enough to enable it and configure it, or to implement basic configuration, but it's really, really pre-release. I'm definitely curious how this will develop, in particular on OS like Windows, because these functionalities with namespaces and C groups and seccomp, that's something completely targeted on Linux. And I guess similar possibilities are available on Windows, but I don't know how Oracle will handle with these or will solve these on Windows. Yeah. Production ready? A question? No, definitely not. But it's something which makes sense if you have time that you start to consider this, probably start to engineer a little bit, in particular for future secure container architecture. One more thing. DB Nest is also available in NTC. So basically, at least there are a few hints. If you check the hidden parameter, you find all the hidden parameter which will become official available in 21C, also in 19C. So DB Nest enabled, DB Nest PDB, fsconfig, fstype, etc. This is all available in a 19C database. You can configure it, so you can use the 21C documentation, then you can set this hidden parameter on a 19C database and enable a nest on a 19C database. So it does work, at least sort of. Definitely interesting if you engineer and test a little bit your database, but here highly not productive. Yeah, I think that's it from my side. I hope I could give you an overview about the upcoming and future security measure on 21C databases and probably the direction where Oracle goes with securing container databases in the future. I'm ready if you have a few questions. And if you look at the recording of this seminar, feel free to contact me over Twitter, web, LinkedIn, etc.
Can you hear me, Stefan?
Yes, I can.
Fantastic. Good. I can see that's no question by the chat at the moment. But if anyone has any questions for you, for sure they can contact you via the platform too, or directly to your Twitter account, to email, and also direct to us too. We can redirect to you too.
Yeah.
Thank you so much, Stefan, for a fantastic presentation. And I know for you is already kind of late in your side of the world. Here is
yeah, I will go to sleep now, and we'll start working tomorrow then. My happy situation is that there are not many Stefan Oehrli, so if you Google for Stefan Oehrli and Oracle, you probably will find me, and the other access information are available via platform. Okay.
Fantastic.
Thank you,
Stefan. Thank you so much, everyone. And please keep enjoying for the other sessions during the next 17 days. Register to them and support these Oracle speakers and also the Oracle community. Mm-hmm. Thank you so much, Stefan. Thank you so much, everyone. And please take care and be safe.
Hi. Have a nice day. Bye, guys.
CloudDB, shaping your new normal.